Good morning, this is Mr. Precella. Today I'm going to work a problem for my business calculus class, Math 1325. Let's see, this involves local extrema. So we're going to have to use the first derivative test. Determine the location of each local extremum of the function. So here's my function. F of x equals x cubed minus 3x squared minus 9x plus 1. So trying to find local extrema, we need to find the derivative. Oh, we know how to do that. That's what? 3x squared minus 6x minus 9. And we need to ask ourselves, where is this derivative equal to 0? And where is it undefined? Well, it's a polynomial function, so it's always defined. So all we need to worry about is setting this derivative equal to 0. And there's a common factor of 3 here. Now I can do this what I'm about to do, I can do it when it's the derivative set equal to 0. I can't do what I'm going to do to the original derivative. But I can say, okay, let's divide 3 by 3. That's the same thing as multiplying by 1/3. And that'll give us 0 equals just 1x squared minus 2x minus 3. And we can then factor. This is a simple trinomial. It falls out very quickly. And we're going to get two critical numbers of x equals 3 and x equals -1. Those are my critical numbers. So we draw our number line. Use green. There's my number line, and I'm going to test the intervals. No, it's a +3 and a -1, isn't it? So there's -1, there's +3. And we're looking at the sign of f prime. Let's see, to the left of -1 on this interval. We could test -2. We could test, you know what I think I'll test? If it's easy to test, is -10, because that's easy to square. So I'm going to test -10. That would give me f prime is equal to, plugging into the derivative here. Here's where I'm plugging in. There's the derivative. Plugging in -10, I'm going to get a 300 plus 60 minus 9. That's positive, so the derivative is increasing. Between -1 and +3, I'm going to test 0. That'll give me f prime equals, that'll be a 0 minus 0 minus 9. That is negative, so decreasing. And finally, to the right of 3, we'll test, I guess a +10 is easy to plug in. I could use 4 if I wanted to. I could use 3.5 if I wanted to. I'm going to plug in something that's easy to plug in. That'll give me a 300 minus 60 minus 9. Plugging into the derivative. That is a positive value, so the function is increasing. So we do have a local maximum and we do have a local minimum. Local maximum occurs when the function is increasing and then decreasing. Local minimum occurs when the function is decreasing and changes to increasing. So we have a local maximum. I think I'll summarize it right up here. We have a local maximum. We have a local maximum at x equals, what was it, at x equals -1. A local minimum at x equals positive 3. But notice the instructions say to type it as an ordered pair. They want the answer as an ordered pair. So we have a local maximum, the x-coordinate is -1. The local minimum, the x-coordinate is a positive 3. Well, how do we get the second coordinate, that y-coordinate? We have to take the x value and plug it into what? That's right, plug it into the original function. So I'm going to take -1, I'll plug it into the original. Let's see. So here, I'll just move down here to the bottom. Here's my scratch work. I'll just use scratch paper instead. Okay. So I'm going to plug -1 into the original function. F of x was x cubed minus 3x squared minus 9x plus 1. That's something you're going to want to remember. If you're creating ordered pairs, you will automatically be plugging into the original function to get that y-coordinate. And that's going to give me what? A -1. That'll become a -3. That'll be a +9 plus 1. -4 plus 10. That's giving me a y value, -4 plus 10 of positive 6. So we have a local maximum at -1, 6. Now we need the local minimum. Plug 3 into the original function. So we're plugging in 3. That would be a 3 cubed minus 3 times 3 squared minus 9 times 3 plus 1. Oh, this is working out nicely. That's a 27. 9 times 3, that's a -27. Oh, another -27 plus 1. 27 minus 27 is 0. So we have a -27 plus 1. That gives me a -26. So the y-coordinate here is -26. So I guess that wraps up this problem. Bye-bye.